Hi, everybody. I'm Jay Myers. I'm the CEO of Next Generation Manufacturing Canada, and welcome to another one of our project podcasts. I'm really delighted to be joined today by Mitch Debora. Mitch is the co-founder, the CEO of Mosaic Manufacturing. He, I know, is an avid water skier. He plays the guitar, big country music fan. But Mitch, welcome here. I'm not going to ask you to hum a song for us, but tell us a little bit about your background and what Mosaic does.
Thanks, Jay. Excited to be here. Yeah, I think you got most of my background. That captures me. Ever since I was young, loved kind of building things and understanding how things work. That ended up taking me down a path going into engineering and material science, and that's when I discovered 3D printing. I remember being in third year university, seeing it. Printers were getting more accessible in price, and thought I need to get one of those. Saved up some money, started a little business where people would order things online. I would print it for them, and that was my introduction to the amazing potential of 3D printing. But I also kind of saw some of the limitations. Printers don't print in different colors at the same time. They only print with limited materials. And understanding that problem is what led to meeting some amazing people at Queen's University through the DDQIC there, and then starting Mosaic Manufacturing almost 8 years ago now. Oh, sorry, Jay, I think you got muted.
Yeah, sorry. You'd think I know by this time. Um, Additive manufacturing has been around for a long time and is kind of mainstream for a lot of advanced manufacturers today, but it's not for everybody. And there are some big challenges in using additive too. So if for companies that are looking at deploying additive in their production processes, I mean, do you just is it just a replacement for existing systems, or is there something really special about how you would consider using additive in your processes?
Yeah, it's a great question. And one thing I like to say when I answer this, given that it's now 2022, is I like to say, if you knew what additive was even three years ago or more, have an open mind to kind of check out what it is today, because it's changed a lot. Almost every component of it has drastically changed, I'd say, for the better, starting with accessibility. The cost of a printer, not only for maybe a home user, but even for businesses, has gotten to that point where it usually now makes sense for any business that makes real products to have one. And that is now true. Hundreds of thousands of small businesses and large ones that have their own printers. The software has become much easier to use. The materials have become broader, and so the number of applications that you can print parts in. I've got a couple examples in front of me, but just for those who can see this, this is a fully flexible, functional insole printed with two materials coming off of an affordable printer, same printer that might make this massive multicolor product enclosure. And so the flexibility of the systems are vast. And so when you look at how and why businesses are using 3D printers, historically and still today, it was all about making prototypes quickly. And that prototype might be for a product you're developing, it might be for a problem you're trying to solve one-off. But then the really exciting thing, and something I have a feeling we'll talk a bit about today, is the forward-looking growth segment of the market, which is production. So, the past few years, we've heard all about supply chains breaking down. And as consumers and businesses, sometimes we don't realize how complex these supply chains are. It starts with raw materials somewhere, manufacturing maybe overseas, ocean freight to a warehouse, distribution center finally makes it to the Amazon warehouse, then makes it to you. That is complicated. It's terrible for the environment, leads to expense. And so if you imagine, in fact, what's behind me is a bank of 3D printers, you automate that, all of a sudden we can be printing products right 1 mile away from where they're needed. So you shrink the supply chain, you shrink the complexity. It's much better for the environment. And this is kind of what they call manufacturing 4.0. It's a much more efficient supply chain and way to make things. And that's kind of what the future of 3D printing is all about.
And of course, then you can make very complicated, very complex parts. Here you can design for functionality rather than design for manufacturing itself. And some of the parts, particularly in the metal additive, are so complex you would never be able to machine them in the first place there. But that all sounds really exciting. But tell us a little bit about Mosaic and how you're moving the needle here in some of the work that you've been doing as a company, and then I'll ask you about some of the projects that you're working on with NGen.
Sure thing. Yeah, so going back to Mosaic's early days, we invented a new technology for multi-material printing. So most 3D printers, and still today, most printers in the market will print with a single material at a time. So you might print with yellow ABS or blue nylon, but combining them together is really critical, and we identified that early. So we took an approach, we built out all the IP, all the tech, and we're really proud that we've kind of dominated that market from then on. So we've shipped tens of thousands of products, effectively upgrading the capabilities of 3D printers. And along that way, we got on the trail of this much bigger opportunity that I just described, using 3D printing for high volume manufacturing applications rather than for prototyping. And so, 5 or more years ago, secretly in the back room, we began working on a product that we call Array. And it is a fully automated 3D printing production system. So it takes many printers, combines them into an efficient package, applies robotics and intelligent software, and it basically is a bunch of printers that run themselves, meaning that for a production order, you might send 500 or 5,000 parts. You come it back on a Monday morning after setting that up on a Friday, and those parts are ready for you, ready for use. For those who aren't as familiar with 3D printing, just to contrast what that would look like without a system like Array, 3D printer is kind of like a microwave. You put a plate in, heat stuff up, then you have to manually go over, open the door, take the plate out, go put the next one in. Because of that, 3D printers are often very underutilized. Evenings, weekends, lunch hours, holidays, they're just sitting there not used, and it's very laborious to run them. And so by applying that level of automation, we're able to allow much higher throughput at much lower cost, which are two of the biggest key terms for manufacturers. And so, yeah, that's kind of the future direction of the company, is that we're working to bring throughput up, costs down, and accessibility, increase accessibility so that manufacturing can happen more locally and can be owned by and democratized by the companies that make the products, reducing that reliance on foreign, complicated supply chains.
So, and quite an opportunity right now, particularly with Array, the automated system, the large scale systems that you've been using. One of the big challenges, of course, with 3D printers is just the scale of the product that you're able to print. So, you're solving some of the big innovation challenges that the entire industry faces here too. But so tell us about. Got 3 projects with NGen, or have had 3 projects with NGen. The first, tell us a little bit about 3D printing face masks for COVID. You and Mosaic and partners were one of the first people to stand up and say we can solve some of the supply problems as the COVID pandemic struck back in 2020, but it wasn't just Mosaic. You mobilized an entire network to 3D print some pretty critical products for COVID. So tell us a little bit about that and what happened.
Yeah. And it's crazy how time that almost feels like forever ago now. It really wasn't that long ago. And this almost feels planned, because ultimately that project was kind of like a microcosm for everything I just described. COVID was happening, supply chains were crippled. It was critical to get parts made quickly. And so building PPE, the face shields that would go over your face and over a mask, were pretty simple construction, a Mylar sheet, a clear plastic sheet, a 3D printed part that would attach it to your forehead, and then an elastic strap. We were able to get the elastic straps and those plastic sheets pretty quickly, but opening up an injection molding tool or CNC machining the other part would have taken forever. So what did we do? We turned to 3D printing. We deployed them, and instead of having one big factory, given that we couldn't have that many people in one space based on social distancing and mandates, we split them up into what I think we called remote manufacturing cells. Which was really just people's, spare bedrooms. So I think we had, don't quote me on the number, I think it was about 25 or 30 different locations across Ontario where people had the printers, they had the material, they had the files, and then we had a network of a couple vans that would go pick up all the parts, bring them together for quality control inspection. This was a couple different partners in Ontario, and together we were able to combine our capacity to be able to make thousands of these, much more quickly than if we would have used traditional manufacturing means. And again, that's kind of a microcosm. That's a specific application. But if you think about, most businesses face that type of challenge. There's time pressure. Amazon is putting this pressure on everyone to be able to deliver quickly, customized products, have them local, 1 hour delivery, and it's causing every business to need to get faster. And so that exact solution that worked for face shields can really apply to automotive parts, orthotics, you name it.
Well, it's a really good example that supply chain resiliency isn't just about the products that you produce. It's how you produce them, and more to the point, the capabilities you have to pivot into producing critical products as required. And I think that's a good lesson as manufacturers are looking at how they build more resilient supply chains. I'm sure you need just in time, but the just in case is really important too. And that doesn't mean building huge systems to produce a high volume product. It's often based on the capabilities of additive, but other advanced technologies too, to become more flexible, to become more agile in being able to pivot to meet critical market demand there too. There's so there are two other projects that Mosaic has. One around mass production metal printing, and the other one around the array technology that you were talking about as well. So tell us a little bit about those two projects too.
Sure thing. So both of those projects are working with multiple other partners, and that's kind of an alignment between our philosophy and NGen's philosophy, which is it's unlikely you're going to be the best at everything. And by working with people who can bring their core competencies and their talent, and if you can find those synergies, you can accomplish a lot more quickly. So let's start with the array project, which is, like I mentioned before, this system that aims to drastically decrease the total cost per part and increase the throughput and scalability of 3D printing so that it can viably be used in more manufacturing applications than it ever could. Very quick tangent. Something that most people might not know is that there are a couple products which are commercially successful and have been for many years using 3D printing, either directly or indirectly. One of them is those dental aligners, Invisalign. They use massive factories of 3D printers. And then some of the other ones are hearing aids and a couple other medical products. But past that, there's very few examples where a company was able to, for example, not go to China for injection molding and instead use 3D printing for a production application. And why? Because the cost is too high. And so we discovered that if we can solve the cost problem, we can solve the supply chain problem. And that's where Array came from. So working with partners who are experts in extrusion, who sort of know this industry and have been operating service bureaus, a couple applications partners who understand and have strong demand to implement additive manufacturing in their factory. And together, it's been over a couple years now, we've been able to get through a ton of the technological objectives of solving the problem. And then something that we love about NGen's support as well is that it's not just about technology, it's about the marriage between technology and commercialization. Because it's great to develop cool stuff and have it on a shelf, but if you don't get it into the factory, in our case at least, in the case of our partners, then you can't drive that impact. And it doesn't, directly impact manufacturing in Canada and the well-being of all of us. So in these past couple of years and in the final couple quarters coming up, we're aiming to get the array technology into full-scale production, getting it out there. And then when the NGen project ends, that product line will continue to scale. And that kind of leads into our second project, which we call Vector. And I can't share as much detail about that one, but working with a couple other amazing partners in Canada on that one. And what we realized is that, sure, you're going to push speed, you're going to reduce cost, you're going to increase scalability and throughput. But then when you look at applications, sometimes there's prerequisites that if you don't meet them, someone will never use 3D printing. As an example, there's some amazing polymers out there. Holding a gear in front of me, this is printed in PEC, one of the most expensive plastics in the world. This is used for surgical implants. Many times you can replace metal with this plastic, but sometimes the plastic won't work. You need metal. And so, like you mentioned, Jay, we've been working on implementing a couple different methods for printing metal on printers. One is a investment casting method, and then one is actually a direct metal printing method, getting those same benefits of taking a digital file and not just printing a prototype, but printing thousands in a couple days. And that's really disrupting the die casting world, CNC machining world. Really excited about where that goes. And then that metal is one example, but there's other sort of forms of post-processing and other things that we could do to impact the cosmetic and mechanical properties of parts, again, to have them be useful in more applications. And so by improving what comes off of the printers, there's more and more of those verticals that we can disrupt with using 3D printing to shorten supply chains. And I feel like I'm repeating myself now, but that's kind of the narrative and what's common to everything that we're working on with our partners.
Well, that sounds good. So you mentioned die casting. Clearly, the automotive sector is a big opportunity here, and probably even more important as as the industry transforms into electric vehicles, more complex parts, lightweight parts, using new materials, and that opportunity to combine materials as well here is going to be very very important too. Are there other verticals that you're targeting, Mitch?
There are, yeah. Contract manufacturing in general is a really good one for us because something that might not be obvious to people who don't spend as much time executing on product development. Let's say you spend 12 months developing a product, right? Something again that is not obvious is that from the day you're quote unquote done developing the product, it's usually 6 to 9, sometimes 12 months before you get the first part off the production line. That is a massive time frame. And why? What's happening in that time frame, we typically call tooling or tooling up. So you make molds, you develop jigs and fixtures, you remake your prototype using different methods that are production that work for production. So instead of a handmade piece of wood, you'll make an injection molded piece of plastic. That transition from final prototype to production costs a ton of money in resources, in market, in time, not being in the market. And so contract manufacturers, people who manufacture products for other people, part of their business is helping people shorten that. And by getting rid of the need to go overseas or locally for injection molding tooling, and by allowing the flexibility of 3D printing, it's a huge one for them. And contract manufacturers, they work in every vertical from medical products to consumer electronics, tier 2, tier 3, they support automotive. And so, really, while we are seeing some density in certain verticals, there's very few markets that are directly impacted by more efficient contract manufacturing. And so that's what's really cool about what we're doing is that there's no single killer application. There really are hundreds of multi-billion-dollar verticals that are coming up because we're not reinventing something. It's manufacturing. It's been around for a while. We're just finding a different way to do it. And that's really powerful.
Right. And, I guess over the last couple of years, it started with COVID and all the shortages there, particularly of, critical products to fight the pandemic. But all the supply chain shortages have just become much more aggravated over the last couple of years. And so not only the shortages, but at the same time, a lot of companies have gone out of the business of supplying parts to certain industries as well. So, and thinking about industries that are very well established in Canada, like the nuclear industry itself, here, where a lot of the parts have actually gone out of production. So what you're doing is a great way to be able to supply on demand and actually improve some of the parts through the 3D printing process that you're using.
Absolutely, yeah. And something you just touched on there that's interesting is I think a lot of consumers can empathize with this one. The spare parts, something breaks in your house, and it's very difficult to get replacement parts, whether it be a bracket that holds up your blinds or a knob on the barbecue, you name it. Oftentimes we throw out expensive things because one part is broken, and for businesses to hold inventory, that's really expensive as well. So it's pretty mind-boggling. But to imagine this massive, massive warehouse of huge, heavy shelves with bins of parts, and then imagining all of that being on a USB drive instead, it's quite the visual, right? And just thinking that USB drive plus a bank of digital manufacturing machines like 3D printers, you're fueling these entirely new industries which didn't exist before, like spare part production manufacturing. And so just like Amazon Web Services and all of these cloud computing companies really disrupted the way that we deal with data, we're now starting to see this mass disruption in the way that we deal with physical products, which it's super cool to see.
Exactly. And I think there's going to be a lot more transformation over the next 5 years too, as This is going to be really important as companies look at decarbonizing, looking at opportunities to reduce waste, and those are some of the benefits that additive brings to the process as well here. Mitch, you were talking about collaboration, and that is a real focus for NGen. And we're really convinced that collaborative solutions are speed up the development process, help commercialization as well, but lead to some really unique advanced manufacturing solutions that, like yours, are really world leading. Here, tell us a little bit about the process of collaboration, what that's meant for you, maybe some of the challenges that you found, or really the benefits of a collaborative approach to product or to process development.
Yeah, this is something that I know I'm preaching to the choir here, but that I think NGen does really well is understanding that as small medium businesses, we understand that collaboration can be really useful, but sometimes collaboration comes with risk. For example, and I'm going to pick out one of our partners specifically because it's one of the most obvious partnerships, but we have 7 other partners who are all equally amazing. There's this company in Quebec called Dyes Design. They are the best in the world. They make extruders for 3D printers. We make 3D printers and high volume printing systems. And so, it seems plausible we could work together, but you have to start working out the legal agreements with who's going to own the IP and how's it going to happen and how are they going to sustain their core business while helping us and vice versa and all that. And so by having the NGen framework to help bring the project together, help on the strategic side, help on the funding side, we had that room to develop that and to have that conversation using the framework of the NGen application, which for those who don't know includes developing an IP agreement, developing a collaboration agreement, getting that papered eventually into a legally binding agreement. And so working with Dyes, we're able to leverage their core expertise in, again, building incredibly efficient extruders. They're able to get confidential information that we understand about our market, what we're growing into, so that they can be tuning their capabilities and software and hardware to the needs of a system like Array and a future system like I described before. And yeah, we both win. We can go off and achieve our goal of commercializing fully automated 3D printing systems, and they can achieve economies of scale and build better technology. And so, and again, there's 7 more examples like that. And when we all come together, there's so many things that happen, like more sets of eyes, more biases, different market reports, different customers that we can share information on because we're not competing with one another. Each other's success helps us be successful as well. So just a few words there on how powerful the partnerships that we're able to establish have been so far.
Well, that's really encouraging. And, there, very frankly, a lot of companies, when we begin to talk to them about process and our expectations about collaboration, say, well, this is too difficult. It's going to take too long. We really don't understand how we could work together with other partners. So just how long did the process take to negotiate collaboration agreements? And as you say, we expect the project partners to figure out how they're going to work together and how they're going to share costs, what they're going to do in a project, but also how they're going to handle their not only share IP, but also commercialize that IP afterwards. So it's a pretty daunting task, or is it? I mean, is it something that is kind of manageable in a short time frame?
Not gonna lie, it's a lot of work, but risk reward. We put a lot of work when there's disproportionate potential, and in this case, there certainly was. So something that NGen does, I think, focuses on is not being a black box, right? You can email NGen and you're gonna get an email back within a few hours being like, hi, I'm Jay, I'm Jillian, let's get on a call. And so demystifying what the process looks like. For me, that was huge because I was able to sit down with somebody from NGen, understand the culture around partnerships and what it's all about. And like with any type of program that you're going into, you need to understand what the goals are. And if you're aligned, things will work out. If you're not, if you're squeezing a square peg into a round hole, it's not going to work. So when we found that alignment, and this is advice that I give to other people that are developing NGen projects, 2 things. One, focus on the partnership first and foremost, right? Get on the call. Hey, I have a crazy idea. You make 3D scanners. We're looking to put a 3D scanner into one of our systems. Should we work together on this? Also, if we do, we might be able to get some funding that helps cover risk and all that. how many units are you going to sell a year? Oh, this many, this many. Oh, that would make sense for me. What about IP? Get through the big things early. And if you can establish a framework, the second piece of advice is to have the project lead really take ownership of driving the project development, because there's 10 big questions NGen makes you answer, and then there's a financial model, and there's this and that. It's too crazy if 4 partners are working on it at the same time. And so those 2 things, establishing the partnership, high-level key terms early, and then having the lead partner drive the application. I think those are things, having gone through it 3 times now, that helped us be more successful going from the first to the third.
Oh, that's really good advice. I have to ask you another question, and it's one that is important, I think, for us in terms of how we kind of strategically look at our funding. I mean, we're unique in one way, in many ways. We've been our program has been renamed from super clusters to global innovation clusters, but I got to say we still think we're super in what we do here. But one of the things that we focus on is providing funding for the actual scale up of advanced manufacturing processes. Now that could be taking a new process and building it into a full scale production capability, or it could be applying technologies in an integrated solution in a manufacturing production system here. And it seems to me that that's an area of sort of where there's a gap in terms of innovation funding, and where it is difficult to find investment and find other sources of funding. But I wanted to ask you, and particularly when you've gone through the development stage with Mosaic, developing prototypes and now really applying those and scaling up production of new processes here. How important do you see our role in that scale up, later stage scale up and development support?
It's I can talk about this for hours, but I'll keep it to 1 minute. It's critical, and maybe to state the obvious. Being competitive in the world of technology means moving quickly, having great people. That takes money, and when you think about it as an operator, you need to find that cash. And there's a few ways. Sell a bunch of something, take the margin. That's something we actually do. Most people don't, but we have a successful product line in the market. We take profit from that. We invest in things like Array, but there's only so much you can do that. Number 2 is to work with partners and like venture capitalists, right? And we've heard the story a million times. Big VC, market's good, offer you big valuation. Market crashes, you're taking a down round. They fire the executive team. When you work with venture capitalists, there's some types of businesses that can work really, really well, but there's many that are not the right fit, not the right time, not the right market, and you become a product to them, and it can be really challenging. So I hear a ton of horror stories about how that doesn't work out. At least at certain phases. And when it does, sometimes it means a quick sale to a US company or dissolving or being bought by someone else. And it doesn't stay Canadian, right? It doesn't get to that next massive level to become that next Shopify. And so then there's that third category, which is super strategic, and that we're all very lucky to be in Canada, for those who are building businesses in Canada, having this ecosystem of non-dilutive partners and strategic partners. When you're really getting started, IRAP, Shred, as you scale up, NGen actually covers kind of that full spectrum. And then there's this whole a plethora of these other programs. Without them, you'd have to look at those first 2 categories, kind of risk selling your soul and going down a path where you lose control and don't achieve your objective. Or the first, you distract yourself so much generating revenue that you get left behind by the company in the US who has 50 million to throw at the problem that you have 100K to throw at. So it's a competitive world. It takes money, and having strategic partners like NGen is critical to kind of be that equalizer.
Well, and as you say, speed is so important today in being able to commercialize, scale up, provide solutions out there, and as well as what you're doing to reduce cost. I mean, this is always the case with manufacturers. We need a solution, but we need one that we can manage and that is fairly as low cost as possible here too. But the other big challenge that the sector's facing is around skills. And I just missed you recently at an event up in Southampton, Ontario, Swerve, which was a great exhibit of local innovation and particularly focusing on additive and robotics for the for the nuclear industry, based at Bruce Power, not too far away. But and I'm sorry to miss you, and glad you had a good weekend there. But what was the why was that important for you to go to? And just as a bit of background, there's a ton of students there, a ton of local people coming in just to explore what the local counties, local companies had on offer in terms of really world-beating innovation. Oh, Mitch, why was it important for you to be there?
Yeah, so Swerve was amazing, and we were really happy to support it. I think it was important for us to be there to physically show how cool technology can be. I thought it was incredible. One of the things that we told the company when we came back 5 years ago, we'd go to events like this, and you'd be explaining to everybody what 3D printing was. There was like one person in the room who knew what it was. Now, most people knew. Didn't matter what age they were, especially the kids, though. They might have said, "Oh, I've never seen a printer in person, but I saw it on Instagram. I saw it on TikTok. This is so cool." And they'd come and they'd stare, and you'd see the gears turning in their brain. And got to give it to the parents too, who brought their kids out, and the parents were asking the right questions. They were saying, going over to our team, hey, Adeline, like you work at Mosaic. What did you study to do that? Hey, Scott, what did you study to do that? And just thinking about that path. And it really feels to me like so different than what it was 5 years ago. The fact that schools in Ontario and I believe Canada are really focusing on getting young women into STEM and breaking down the barrier and just getting kids excited from when they're young, so that as we think about the future workforce, there's lots of people that are ready to join these types of teams that build technology and truly innovate. Because as we know, the workforce is going to look very different in the future than it looked in the past. And so getting kids excited genuinely before they start to learn math, so that their teacher can say, "Oh, you want to do engineering or product development or software one day? That's why math is important." That spark is so important to get going early on.
Yeah, the kids were really excited, and what amused me, they ran in and they were heading into the games area. And there were two things that caught them. Your display was one, because they all stopped around 3D printing, and then the other part of it that stopped them were all the robots that were walking around as well. So it wasn't just gaming, although as we've been saying in our Careers of the Future campaign too, if you like gaming, well, what better place to do it than working in an advanced manufacturing company today. Mitch, I hope you're still there. You're frozen on my.
I am. Oh no.
Yeah. Sorry, but we're having a few technical difficulties here. But let me just close too, in terms of well, first of all, your pitch to young people who might be considering additive or considering the whole field of advanced manufacturing. What would you say to them in terms of why they should consider a career in that sector?
I've thought a lot about this, and I think young people, we want to have impact. They want to be able to control the future, and I think there's opportunity for such a bright future in so many ways. Some of the things that we look at, like climate change and like a diminishing workforce and quality of life, these are things that we're starting to grasp and have the chance to impact. And if you're excited about technology, and if you see maybe a 3D printer or video games and you think that's cool, there's a path for you to be directly involved in that. And that path starts with studying the sciences and maybe taking a summer job, getting involved and following that passion. And then what I think you'll find that's really cool is at a really young age, you'll be able to start being the one who's developing and designing that, whether it be one line of code at a time or one robot being developed at a time. And then, by the time you're midway through your career, you're going to be able to look back and say, like, I developed that robot, or I solved this problem, or I helped climate change in this way. And so I know these things sound big and scary, but there is a path for you to get there, which is really, really cool and really high impact. And so that's kind of my pitch as to why, if you're interested in technology, it's a great path to go into.
Well, you've been a great champion of advanced manufacturing and working with young kids to attract them into the sector, and for everybody else who wants to see what NGen's doing and what Mitch has to say about this for young people, check out careersofthefuture.ca, because there's some really good material there for educators as well as for parents and young people as well about advanced manufacturing, about additive technology, and about some of the great things that Mitch has been talking about too. One last question before I let you go. What's next on the agenda for you and Mosaic? Where do you want to take the company from here?
Yeah, if sometimes it feels like we're on a rocket ship and it's moving really quickly, and that's exciting. For context, thanks to the support of NGen and how the market has responded to what we've already done, the company's grown from about 20 people to just about 60 in the past 2 years, and that growth is continuing and being sustained by the demand we're seeing for that problem we're solving of using 3D printing in manufacturing. So if we flash forward 5-10 years. I think success will mean that we are powering a meaningful number of factories, that when you buy something on Amazon or the equivalent, some percentage of those products will be printed locally when you order it. It means that we will have brought a lot of manufacturing back to Canada, into North America. And again, those key metrics that we're going to go after to make that possible is making printing more accessible, bringing down the cost, increasing the scalability and throughput. And by doing those things, we'll be able to really go after a big portion of that manufacturing market. So we're here, we're in Toronto. We're always growing. If people are interested, feel free to add me on LinkedIn, shoot me a message that you listen to this, and always happy to have a chat, to tour people around. Like you said, Jay, we love engaging with young people, really with anybody, getting them excited about the future of 3D printing and additive manufacturing. So yeah, feel free to reach out.
Oh, that's super. Well, listen, I'm looking forward to seeing the conclusion of the projects and the outcomes. I know it'll be excellent, and you've had a great record already, and the growth of Mosaic I think speaks for itself, and also want to say speaks for the power of being able to develop these capabilities within Canada and scale up a business in Canada without exiting prematurely. Here we need more companies like Mosaic, and particularly in the advanced manufacturing sector. So listen, Mitch, congratulations! Thanks so much for joining us today, and to everybody, feel free to contact Mitch at Mosaic. Thanks a lot for joining us.
Thanks for having me and for all the support.
Cheers.